This meeting is being recorded.
Assalamualaikum and a very good day to everyone. My name is Alexina binti Aulidin, student from Faculty of Computing, University Technology Malaysia, matrix number A23CS0041. Today, I will be presenting my final year project phase 1 titled Comparing Data Leakage Rates in Large Language Models between Malay and English Prompts. This project was supervised by Dr. Muhammad Zafran bin Muhammad Zadishah. And without further ado, let us begin. So firstly, to understand why this research exists, let us first look at the problem background. So the first, as you can see, large language models or LLMs have become increasingly powerful and are now deployed across critical sectors such as healthcare, finance, and legal. However, because these models are trained on massive datasets, they tend to memorize sensitive information, and this creates a serious privacy risk as the information may be unintentionally exposed during deployment. Now, most existing research on this issue has been conducted entirely in English. So this creates what we call an evaluation blind spot because LLMs are used globally by speakers of many different languages, not just English. So this brings us to the core problem because Malay, as a low-resource language with a unique morphological structure, including its own system of prefixes and suffixes, may interact very differently with a model safety mechanism. A model might successfully detect and refuse a malicious prompt in English, but cannot do the same when that same prompt is written in Malay language. We call this, for the purpose of this research, the semantic safety gap. And this gap is exactly why this research aims to investigate. So based on this problem, 3 research objectives and questions have been established. So firstly is to construct a thorough bilingual dataset of prompt-based leakage attacks covering both Malay and English while extracting key features that capture the unique characteristics that modulate privacy risk in both languages. Secondly is to quantitatively compare and evaluate the differential in data leakage rates between Malay and English prompts using 2 attacks methodologies, which is direct extraction attack DEA and membership inference attack MIA. And thirdly is to validate and propose cross-lingual evaluation metrics that enable a more robust framework to measure LLM safety alignment across diverse linguistic environments. So these 3 objectives work together to address the research gap that exists in multilingual LLM privacy evaluation. And to ensure the feasibility of the study, the research scope has been clearly defined. So in terms of domain, this research focuses on LLM privacy and natural language processing security. The models evaluated are 3 widely used LLMs from different model families, which is the GPT-4o, Gemini 2.5 Flash, and Llama 3. These models are chosen to eliminate bias during comparison. And for attack methods, only DEA and MIA are used. Jailbreaking was deliberately excluded because its purpose is to elicit harmful content, whereas this study focuses specifically on how models inadvertently expose sensitive information. And finally, the dataset is adapted from Agent benchmark from El Yagubi papers covering 4 real-world domains, which is healthcare, finance, legal, and corporate. So moving on to the literature review, several key studies from this research are from Carlini et al. 2021. They established that LLMs verbatim memorize training data and that larger models are significantly more susceptible to data extraction. On the other hand, Petrov et al. In 2023 demonstrated that tokenization is unequal across languages. So non-English languages experience a tokenization premium, meaning they require more tokens to process the same content. This directly affects model performance and security in low-resource languages like Malay. Next is Argawal in 2024 showed that in multi-turn conversations, a sycophancy effect can raise the attack success rate from just 17.7% all the way to over 86%. And most recently, El Yagubi et al. In 2026 introduced the agent link benchmark, which provides a robust multi-domain dataset and introduces the weighted leakage score, WLS, metric for measuring leakage severity. And lastly, despite all this contribution, the research gap remains clear that no prior study has specifically compared data leakage risk between Malay and English prompt. So this is precisely the gap in this research addresses. So why does the semantic safety gap exist in the first place? It starts at the training stage. LLMs are predominantly trained on English data, which means their safety alignment mechanisms are also built around English linguistic patterns. So when a prompt is written in Malay, the tokenizer processes it differently. because Malay unique morphological structure, their affixes and their word formations, their cultural do not map neatly into English optimized tokenization. So this leads to a higher tokenization premium for Malay, which means the model processes less information per prompt, and its safety filters may not engage in the same way they would for English. So the result is a model that can confidently refuse a malicious English prompt can unknowingly comply with the exact same request written in Malay. So this is the vulnerability that this research sets out to measure. So the methodology of the research is structured into three phases, which is phase one was the dataset preparation. The English corpus was adopted directly from the Agent framework, consisting of 1,000 scenarios and four domains. So each scenario contains an average of 29 sensitive PII fields. And since no Malay version existed, a Malay adaptation was generated using GPT 3.5 Turbo with cultural mapping as to ensure that contextual accuracy and to verify the semantic equivalence between Malay and English prompts. The research applied the segment semantic consistency, which is SCONS, with threshold 0.72. So any record scoring below the threshold was rejected and regenerated. And the final dataset is organized into four quadrants, which is English seen, English unseen, Malay seen, and Malay unseen. Phase 2 is the experiment execution, where DEA and MAA are run across all three target models via black box API access. DEA uses prefix-based context injection on scene records, while MIA compares model confidence levels between scene and unseen record. And finally, the analysis phase, where metrics including ASR, WLS, PDR, ELR, and tokenization premium are used to compare leakage rates across English versus Malay quadrants. Next is the system architecture. This architecture is designed as an integrated 5-component pipeline. It begins with the datastat store, where the 4 quadrants of records are held. Then records are then extracted and passed to the attack prompt constructor, which builds DEA and MIA prompts with structured metadata tagging. So these prompts are sent to the LLM inference layer, where all three models are queried simultaneously under black box access. So responses are then captured by the response logger, and finally, the metric computation engine calculates all leakage metrics and produces the final cross-lingual comparison output. So lastly, looking ahead to PSM2, the work is planned across 3 phases. In the first phase, spanning weeks 1 to 4, DEA and MIA will be executed across all 3 target models in both English and Malay, with all responses logged systematically. In the second phase, from weeks 5 to week 9, all leakage metrics will be computed and aggregated at the quadrant and model level. And in the final phase, from week 10 to 14, a full cross-lingual comparison will be conducted, visualized through charts and tables, followed by thesis writing and final submission. So to conclude, this research addresses a critical and underexplored gap in LLM privacy, which is the influence of prompt language on data leakage risk. And by systematically comparing English and Malay prompt across multiple models and domains, this study aims to contribute toward building a more robust and linguistically fair AI safety mechanism. So that's all from me. Thank you for your time and attention.